Space has always fascinated people. We look up and wonder what is out there. The James Webb Space Telescope, or JWST, is humanity's latest tool for exploring the universe. Launched in December 2021, JWST is the most powerful space telescope ever built. JWST's gold-coated mirrors are huge. They let it collect more light than any telescope before. This means JWST can see farther back in time, all the way to the first galaxies. It looks at stars, planets, and the gas and dust between them. JWST's cameras and instruments are designed to study the universe in infrared light. Infrared light is special. It lets JWST see through clouds of dust and gas that would hide objects from other telescopes. In a way, JWST is like a super-powered set of night vision goggles for space. It helps us find things we have never seen before. With JWST, we are not just looking at stars and galaxies. We are also searching for planets beyond our solar system. These are called exoplanets, and finding them is one of JWST's most exciting missions. In 2024, JWST made a groundbreaking discovery. It found its first exoplanet, TWA-7b. This planet orbits a small young star called TWA-7, which is located about 150 light-years away from Earth. Finding TWA-7b was not just another tick on a list. It was a moment that showed what JWST can really do. Why is TWA-7b important? For one, it is the first new exoplanet that JWST has found using direct imaging. This means scientists took a picture of the planet itself, not just its effect on its star. That is a big deal. Most exoplanets are found by measuring a star's light and looking for tiny dips or wobbles. The discovery of TWA-7b also shows that JWST can find planets in places that are hard to reach. TWA-7b orbits within a disk of dust and debris around its star. These disks are often messy and bright, making it hard to see anything else. But JWST was able to look through the dust and spot the planet. This discovery is a sign of new possibilities. JWST has proven that it can find new worlds where other telescopes might struggle. TWA-7b is just the beginning. Meet TWA-7b. An exoplanet is simply a planet that orbits a star outside our solar system. There are thousands of exoplanets out there, and each one is different. Some are giant and hot, others are small and cold, some might even be like Earth. TWA-7b is special because of its mass and where it lives. Scientists think TWA-7b is about the same mass as Neptune, or maybe a bit lighter. That makes it one of the lightest exoplanets ever found using direct imaging. And it's not close to its star but far away, about 100 times the distance from Earth to the Sun. TWA-7b's home is a dusty debris disk. Imagine a wide belt of rocks, ice, and dust swirling around the star. This is like our solar system's asteroid belt, but much larger and brighter. These disks are where planets are born, so finding a planet here is like catching a fish in a very crowded pond. The discovery tells us that planets can form in tricky places. TWA-7b stands out not just for its size, but for where it lives and how it was found. Finding an exoplanet directly is very tough. Stars are extremely bright, and planets are faint. It's like trying to spot a firefly next to a lighthouse from far away. Most of the time, the star's glare hides the planet completely. JWST used a special tool called a coronagraph to help. A coronagraph is like putting your hand in front of your eyes to block the sun, so you can see the birds flying nearby. In JWST's NIRCam instrument, the coronagraph blocks out the star's light, making it possible to see what is around it. But it's still not easy. The debris disk around TWA-7 is bright and full of dust. JWST's infrared vision helps by seeing heat, not just light. This lets it see the planet glowing faintly in the cold of space. Scientists then used advanced computer programs to pick out TWA-7b's faint signature from the noisy background of dust and debris. This method, direct imaging, is one of the hardest ways to find a planet. But it gives us an actual picture, not just a hint. Thanks to JWST's technology, we can now see planets in places we could never reach before. Most exoplanets found by direct imaging are giants, many times the size of Jupiter. That's because, well, big hot planets are much easier to see. They glow more brightly in infrared light. Finding a small, cool planet like TWA-7b is like finding a needle in a cosmic haystack. TWA-7b has a mass similar to Neptune, which is about 17 times the mass of Earth. This makes it much lighter than most directly imaged exoplanets. Until now, most planets found this way were several times heavier. JWST's sharp vision and sensitive instruments made it possible to find lighter, fainter planets. Why does this matter? The lighter the planet, the more it can tell us about how planets form and change. Smaller planets are more common in the galaxy, but they are also a lot harder to spot. Seeing TWA7b means we might be able to find even smaller planets in the future. Finding TWA7b sets a new standard. It opens a door to discovering many more lightweight exoplanets and learning about their secrets. Planets are born in swirling disks of gas, dust, and rocks around young stars. These disks are messy, full of raw materials. TWA7b is living proof that planets can form and survive even in such crowded places. The debris disk around TWA7 is bright and thick. It is a busy place with lots of collisions and movement. Some scientists think the presence of TWA7b might be shaping the disk itself, creating gaps or rings as it moves through the dust. This is similar to how Jupiter's gravity shapes the asteroid belt in our own solar system. Studying TWA7b helps us understand how planets grow and change over time. Was TWA7b always this size? Did it move outward after forming closer to its star? Or did it form far away, gathering up dust and gas from the outer parts of the disk? These are questions scientists are now trying to answer. The more we learn about planets like TWA7b, the better we understand our own solar system's history. Each new discovery adds a piece to the puzzle of how planets and systems evolve. People often ask if a new exoplanet could be home to life. In the case of TWA7b, the answer is almost certainly no. TWA7b is a gas giant, similar to Neptune. Gas giants do not have a solid surface. Their thick atmospheres are made of hydrogen and helium, with no place for life as we know it. TWA7b is also very far from its star. It receives much less energy than Earth does from the sun. This makes it a cold, dark world. Even if it had moons, they would likely be frozen and inhospitable. The environment is nothing like the warm, watery worlds where life might thrive. However, studying TWA7b is still important. It shows us the variety of planets that exist in the universe. Some scientists wonder if moons of giant planets like TWA7b could have oceans under their icy surfaces. While that is unlikely here, it gives us ideas for searching elsewhere. TWA7b is not a second Earth, but it helps us sharpen our search. Each planet we find teaches us what to look for next in the quest for life. TWA7b is just the beginning for JWST. Already, the telescope has helped confirm or study other exoplanets by analyzing their atmospheres. But finding a brand new world using direct imaging is a thrilling step forward. With its powerful instruments, JWST will keep searching for even smaller and fainter planets. Scientists hope it can spot rocky planets, maybe even ones the size of Earth. These worlds could be hidden in the habitable zones of their stars, where temperatures are just right for liquid water. JWST is also looking at the atmospheres of known exoplanets. It can detect gases like water vapor, methane, and carbon dioxide. By studying these fingerprints, scientists can learn if a planet's atmosphere might support life, or if it is toxic and harsh. The hunt for new worlds has just begun. With each discovery, we get closer to answering the age-old question: are we alone in the universe? Space exploration is about more than collecting data. It is about feeding our curiosity. Every new discovery, like TWA7b, reminds us how much there is left to learn. It shows us that the universe is full of surprises, waiting to be found. When we find a new planet, we expand the map of our cosmic neighborhood. Each world tells a different story. Some are hot and wild, others cold and lonely. All are part of the grand story of the universe. TWA7b is a symbol of what JWST can do. It stands for new technology, new ideas, and the power of teamwork. It inspires young people to ask big questions and dream of exploring beyond Earth. The stars above remind us that we are part of something vast and mysterious. As we keep searching, we remember that curiosity is our greatest tool. The journey is only beginning, and the universe awaits our next discovery.